the graph of y equals L1 of x. To understand it, we need to recall calculus 1 knowledge. So if you're using your graphing calculator, you see the domain of Ln of x is from 0 to infinity. And the graph will look like this. Okay, so what it is it's an increasing graph, is concave down, and as x approach, x is near 0, the function value, the y value, is approach negative infinity. And as x approach infinity, the y value is approaching infinity on the top. So how do we understand this? So first, limit as x goes to positive infinity, L1 of x. Why this graph behave this way? You have to go back to the definition of L1 of x. So, or the definition of a limit. So let's say this limit equals a number L, okay? And we said it's actually infinity. So what it means is given any large number m, we can find x greater than a number such that this limit, or the function value, so Ln of x, will be greater than any given value m. So how do we choose this value? Well, we just choose it to be e to the m plus 1. So what it means is Ln of e to the m plus 1, well, it's just an exponent, m plus 1. M plus 1 is obviously greater than m. So we can always find such an x or a value such that when x exceeds that value, we are bigger than any given number. In that case, this limit, we call it, is equal to positive infinity. Similarly, limit as x approach 0 from the right, that means it's a little bit bigger than 0. So it's a positive number. Ln of x will equals negative infinity. Similar approach, given any negative number, you choose the exponent to be, well, x has to be less than a certain number but bigger than 0. Similar number, okay, e raised to that power, then you get the desired result for the limit. So that's a review for the limit. For what about the increasing nature of this graph? So it's increasing. How do we relate it? We have to go to the first derivative test or theorem, first derivative. So if y prime is always greater than 0, then the graph of the function y is increasing. So what is Ln of x? And then you take the derivative. It's 1 over x. Well, the domain is x greater than 0. So that what it means is the first derivative is positive. In that case, the graph is increasing. Now what about the second derivative? So y double prime. So the second derivative is the derivative of the first derivative, which is negative 1 over x squared. You use the power rule. Well, 1 over x squared, anything square and x is non-zero, is positive. Negative of a positive number is less than 0. So the second derivative is less than 0. So what it means is the graph for this function concave down, okay? And you can see it from the graph. And last but not least, okay, so that is the second derivative theorem. Last but not least, we want to talk about the mean value theorem. So we know Ln of 1 equals 0. This is the intercept right here. X equals 1, y equals 0. And Ln of a number, like a large number, maybe 100, right? Use numerical integration method, you find out, oh, that number is greater than 1. And as a limit, you can tell it can be arbitrarily large. So what it means is, in between this 0 and this large number, or maybe you can say greater than 2, okay? 1 is between 0 and 2. So the mean value theorem guarantees that there is a value Ln of a value that will give you the number 1. And we call that value E. So we define E is a value such that Ln of E equals 1. And you can, again, use some numerical method to find out E is approximately 2.718 and so on. And that is an important number for us to understand. It's an irrational number, and it cannot be written as a decimal that ends or repeat. That's what it means as an irrational number.